So let's apply this. So I've given you 3 different boxes. And of these 3, you can see I've drawn on there the forces that are acting on the 3 boxes. And what I want you to do is pause this video and ask yourself which one of these could be moving at a constant velocity. Remember, requires a net force to change something's velocity. If I'm changing something's velocity, that means it has acceleration. So I need a net force. So pause it and come back. Okay, so let's take a look. So at a constant velocity, that means all of the sum of my forces need to be 0, because it doesn't specify a constant velocity in the x or the y, it just says a constant velocity. So I look at this one, and I have an 8 Newton force to the right and an 8 Newton force to the left. So in the x direction, this thing isn't accelerating, but I have a 7 Newton force going up and a 2 Newton force going down. That means I have a net force of 5 newtons going up. So this one is accelerating in the y. This one though, let's see, I have 10 newtons left and right, so both in the x canceling out, so I'm not accelerating there. I have 10 newtons up and 10 newtons down, so I have a no net force in the y. This one is either of 2 things. It's either stopped or moving at a constant velocity. And at constant velocity could be in the x or it could be in the y. We don't know. We don't know. I come over here, I have 1 Newton going to the left. This could be like something like friction. And 9 newtons going to the right. So that means that I have a net force going in the positive x direction. Let's go ahead and define that real quick. And what I'm defining as the positive x direction. So to know what my acceleration is, well, for this first one, I only have a net force in the y. And I don't know if you can see that I've written those to be all 1 kilogram. So let's see, I have a 7 Newton force in the positive direction. I'll do a different color. So I have 7 newtons in the positive y, minus this 2 Newton force is going down, so minus the 2 newtons equals mass times acceleration. So I can simplify this to, I have 5 newtons equals 1 kilogram times acceleration. Or 5 divided by 1, I am accelerating at 5 meters per second squared. Sweet. And my sign, let's see, is positive, so I would be in the y direction. So that's my acceleration, is in the positive y direction. This one, no acceleration, so we don't need to do anything with it. This one only has 2 forces acting on it, and those 2 are in the y. So let's just call this 1, 2, 3. So this is for 1. So for 3, let's see, I have a force in the positive direction as I've defined it. So I have the sum of forces in the x is going to give me this positive 9 newtons minus this 1 Newton is going to equal mass times acceleration. I have a net force, I'm accelerating. So that means that I have 8 newtons equals mass times acceleration, or this time I'll divide by my 1 kilogram, equals acceleration A. So this one has an acceleration of 8 meters per second squared. And it seems like this is a good time to kind of take a look at what the units of newtons are. And what I always tell people is this becomes this force net equals MA. And we know that this is a Newton. That's just what we've called it. There's nothing secret about that. We got tired of writing this kilograms times meters per second squared. So our masses in physics are always kilograms, and acceleration is meters per second squared. So this thing here is what we get tired of writing over and over again. So physicists cheat, and we just call that thing a Newton. So if I have a Newton and I divide it by a kilogram, I'm left with the units of acceleration. It's one of the ways you can double check your work.